Ever pondered why a cricket ball, when bowled, sometimes veers in the air and alters its course? It's a curious thing, isn't it? Such is the charm of cricket, a game that has wowed audiences for generations with its intricate strategies and captivating dynamics. What might seem like a leisurely sport played on a sunny afternoon is in fact a game of precision, tactics, and physics. The phenomenon in question, the mysterious veering and alteration of the flight path of the cricket ball, is no mere chance or luck. It's an art, mastered by a select few bowlers who have over time perfected this skill, turning games in their favor in a matter of minutes. This unique aspect of cricket is fondly known as swinging bowling. In essence, swinging bowling is all about making the ball move in the air after it has been delivered, causing unexpected deviations in its course. This unexpectedness is what makes this game so thrilling, keeping spectators on edge, biting their nails in anticipation. It's a science in itself, a study in fluid dynamics and aerodynamics at play. When a bowler propels the ball, it slices through the air, causing air pressure to fluctuate on either side of the ball. This differential air pressure, coupled with the bowler's technique and spin imparted on the ball, causes it to swing. The speed, the seam position, the weather, even the condition of the pitch can influence this swing. If we delve deeper into the science, we will find that the principles of Bernoulli's equation and Magnus effect come into play. When the ball is delivered and spins in the air, the faster side creates less air pressure, while the slower side creates more. This difference in air pressures causes the ball to swing in the direction of the lower pressure. It's an intriguing interplay of forces, isn't it? Bowlers such as the legendary Wasim Akram or the contemporary James Anderson have turned this science into an art form, consistently making the ball dance to their tunes, leaving batsmen bewildered and audiences thrilled. Yet, swinging bowling is not just about the science, it's about practice. It's about the countless hours spent on the pitch, learning to control the factors that make the ball swing. It's about understanding the nuances of the game, the tiny details that make a huge difference. Indeed, swinging bowling is a testament to the beauty and complexity of cricket. It's a phenomenon that illustrates how a simple game of bat and ball can transform into a battlefield of strategies and tactics. Today, we explore the captivating aspects of cricket and dive deep into this phenomenon known as swinging bowling. At the crux of understanding swing bowling and cricket lie the foundational principles of physics. It's a fascinating amalgamation of science and sport that has been refined and perfected over years by cricketers worldwide. Now, one of the critical concepts that governs this phenomenon of swing bowling is something called Bernoulli's principle. Named after the Swiss mathematician Daniel Bernoulli, this principle is a pillar of fluid dynamics and has wide-ranging applications, one of which interestingly happens to be in the world of cricket. The fundamental assertion of Bernoulli's principle is that an increase in the velocity or speed of a fluid corresponds with a decrement in its pressure or a reduction in the fluid's potential energy. This principle has been instrumental in explaining many physical phenomena, varying from the lift of an airplane wing to our everyday act of drinking through a straw. But in the context of cricket, it provides a scientific explanation for the swing of a cricket ball. Let's imagine a ball soaring through the air, cutting across the sky with a certain level of elegance, an element of uncertainty, and a touch of complexity that is not immediately obvious. The air, acting as the fluid in this scenario, behaves disparately on the opposite sides of the ball. The forces that come into play are not uniform, creating a unique and intriguing scenario. The side of the cricket ball moving against the direction of the air, the rough side, encounters more air resistance, colloquially known as drag. This drag is a force that opposes the motion of an object through a fluid. In the context of our cricket ball, the rough side, with its uneven surface, creates more friction with the air molecules, thus experiencing more drag. On the contrary, the other side, the smooth side, presents a different story. It comes across lesser resistance from the air. The polished surface, being more streamlined, allows the air to flow over it with less friction, thus leading to reduced drag. This juxtaposition of the opposing forces, or the variation in air resistance or pressure on both sides of the cricket ball, is the main actor in this scientific drama. It's the force that induces the cricket ball to swing, to deviate from a straight trajectory and move in an arched path. The cricket ball, following the rules laid down by Bernoulli's principle, will always swing towards the side that experiences less pressure or resistance, which in this case is the smooth side. This is the reason why cricket bowlers often dedicate time to meticulously polish one side of the ball, keeping it smooth, while allowing the other side, the rough side, to become worn and uneven. The dichotomy between the two sides creates the conditions necessary for the swing to occur. This small yet crucial practice gives a scientific edge to the bowlers, furnishing them with a subtle weapon to outwit the batters. It's a testament to the fact that science and sports are not mutually exclusive, but rather intertwined in a complex dance. In the end, this explains why cricket bowlers often polish one side of the ball, keeping it smooth, while allowing the other side to become rough and worn. Indeed, there's more to cricket than what meets the eye. It's a game of strategy, precision, and skill, where even the elements of nature like the wind and humidity can influence the outcome of a match. Now let us delve a little deeper into the intricacies of the sport, and especially the phenomenon called swing in cricket. The swing in cricket, that sudden deviation of the ball in midair, isn't simply a product of the bowler's skill and finesse, but also hinges significantly on the speed at which the cricket ball is delivered. The role that velocity plays in swing bowling cannot be underestimated. It's a pivotal element that can turn the tide in a game. Imagine for a moment a bowler running up to the crease armed with a strategy. He knows that the speed at which he delivers the ball can either make or break that strategy. In this realm of speed and precision, there exists a sweet spot, a golden range, so to speak, that ranges from around 70 to 85 miles per hour. It is within this zone that the swing is most impactful, most unpredictable, and most lethal for the batsman. Deliver the ball slower or faster than this range and the swing loses its potency, its charm. It becomes just another delivery, devoid of the potential to surprise and unseat the batsman. But the speed isn't the only player in this game of swing. Other factors come into play, adding layers of complexity and intrigue to the art of swing bowling. One such critical factor is the angle at which the cricket ball is released. The release angle can drastically alter the outcome, causing the ball to swing away or towards the batsman, adding another layer of uncertainty to the game. Another key factor is the seam position of the ball. The seam position plays a critical role in determining the swing. When the seam is angled instead of being straight, it disrupts the otherwise symmetrical flow of air around the cricket ball. This disruption creates an asymmetrical airflow, curving the path of the ball, resulting in a swing. It's these subtle intricacies that elevate cricket from a mere game to a symphony of strategy, skill, and science. When the swing is executed correctly, it can deceive even the most experienced of batsmen, making cricket a game of unexpected twists and turns. It's this unpredictability that beautifully encapsulates the charm of cricket. When the seam is angled, it creates an asymmetrical flow of air around the cricket ball, resulting... Now, let's wrap it up. The scientific principles at play in cricket bowling involves Bernoulli's principle, the difference in air pressure on either side of the cricket ball, the speed at which the ball is bowled, and the angle of the seam. It's a fascinating of physics and cricketing skill that makes the phenomenon of swing bowling and cricket possible. So, the next time you witness a bowler swing the ball in a cricket match, you'll be amazed not only by the player's skill, but also by the intriguing aspects of the game that make it all possible. It's not just sport, it's cricket, a display of strategy and skill in action.